Find the domain and range of the relation. We're shown a set of ordered pairs. First ordered pair is -2, 4. Second ordered pair is 7, 6. The third ordered pair is 5, 8. The fourth ordered pair is 13, -5. And the fifth ordered pair is 12, 9. Now, when we're talking about the domain and range of a relation, the domain is defined as the domain is all the set of all possible. Let's go ahead and say it that way. The set of all possible x values, or values for the variable x. And we could go ahead and let's change to like red maybe to talk about range. Range of a relation or a function. The range is the set of all possible y values, or values of y. And of course, when we're talking about values of x and y, we have to remind ourselves that each ordered pair shown is shown as two numbers separated by a comma, and all of it surrounded by parentheses. The first number represents a value of x, and the second number represents a value of y, and they're associated with each other. There's some relation out there. Sometimes the relation rises to the level of function that forms a relationship between these two variables. It could be an equation, typically. But right now, we just for this purpose of this problem, we're given 5 sets of ordered pairs, in which the first number is an x value and the second number is a y value. And that's true for each of these ordered pairs. So when we're going through each of those ordered pairs, I think we could think in colors, because I'm a believer in colors, use of color during math work. We're going to think about x as a blue. We're going to associate blue with domain, and we're going to think about the values of y in red, because red is, for the way I'm explaining it, is associated with range, which is red. So what we should do, I think, to help explain the problem, is we're going to write out the set of ordered pairs as it was provided to us. So here are the ordered pairs, and the whole set. We have a set of -2, 4. Then the next ordered pair is 7, 6. The next ordered pair is 5, 8. The next ordered pair is 13, -5. The next ordered pair, last one, is 12, 9. And that completes a set. These are set symbols. So we're being given a set of ordered pairs. Now, if we are looking at the first number as the first number of each ordered pair as a value of x, then we can simply start looking at this is a value of x, this -2. The first, coordinate, first number, the first value has all those meanings. The first number in an ordered pair. The order of any ordered pair is alphabetical. It's x then y. If it was an ordered triple, it'd be x, y, z. What's that called? A, B, C, x, y, z. It's alphabetical order. So the first number is an x. The second number is a y. Well, if I'm looking for domain, and if we're following the directions of the definition of that we wrote up above here, the domain is a set. It's the set of all possible x values. So it's going to be formed by all the values that we're seeing here. The first values, the x values. So the first value is a -2, comma. What's the next one? Well, 7 represents an x value, so we're going to put 7 in. we're going to make a set containing all the x values from each of the ordered pairs. And we have a 5. And we have next an x value is 13. So each of these items in the list are separated by commas. And we have another value of that is 12. So we comma 12. And I'm just going to go back and check. -2, yep. 7, yep. 5, yep. 13, yep. 12. I close my set. We've just represented all of the x values from each of the ordered pairs. Now we're going to come back, and of course we're going to do the same to answer the question. They wanted the domain and the range for this relation. So we're going to come in and say the range is a set of all the y values in each of the ordered pairs. So what's the first y value we see? The second number in each ordered pair is a value of y. So 4, comma, the second coordinate, the y coordinate of the second ordered pair is a 6, comma, the third ordered pair has a y value of 8, comma, the fourth ordered pair has a y value of -5, comma, and the last ordered pair has a y value of +9, and just 9. I'm going to go back and check these, make sure we got them all in here. 4, yes. 6, yes. 8, yes. -5, yes. And +9. So I'm going to close the set. Close brace. Now, we prefer to write these in order from small to large, like -2, like negatives are smaller than positives. So then we'd increase in value like -2, 5, 7, 12, and 13 for domain, for example. We would prefer that for range as well. However, many of the questions that we are given, the answer choices that were provided, are often not in order. So our task is to choose in a multiple choice test the best answer of the ones that are available, and that would mean one of these 4. We have to choose one of these 4 answers. So we just need to make sure that each of these x values, for example, are in one of these 4 answers, and they don't necessarily have to be in any order when we're taking a test. So I'm looking for all these domains. We're going to restrict our view to domain first and see which one of these answer choices contains all the information that needs to be there. Okay, I need a domain to have a -2. I don't see any -2s in answer A. I don't see any -2s for the domain in answer B. I do see a domain of -2 in answer choice C and answer choice D. Okay, next I'm going to look for an answer choice that has domain entry of 7, but because we don't see any -2s, all the proper elements in A and B, I'm going to eliminate those as possibilities right now. The answer choice had better be between C and D, at least my initial thinking. Does either of those answers have a +7? Well, I'm looking at this guy, and I don't see answer C selection, and I don't see a 7 in there. And I know a 7 was in this ordered pair right here. So I'm going to immediately eliminate C. I suspect answer D is going to be our choice. Let's make sure everything is in there. Okay, was there a 7? Yes. Next answer, number that we have is a 5 in our domain. Is there a 5 in answer choice D's domain? Yes. Is there a 13? Is there a 13 in answer choice D? Yes. And finally, is there a 12? Yes. Very good. The domain is correct. For good measure, I will definitely double check that the range that they're showing here in answer choice D has all of our elements. And then we'll draw another conclusion. Look, even if it didn't, the closest thing we have in range is correct. I would still probably choose answer choice D because I have to choose something. I don't want to leave any answer choices blank for exams that don't penalize me for guessing. So it's a win-win, if you will. Okay, range. Does it contain a 4 for answer choice D? Yes. Does answer choice D's range include a 6? Yes. Does it include an 8? Yes. It's looking good. Does it include a -5? Yes. And finally, does answer choice D have a 9? Yes. The range shown for answer choice D is, in fact, contains everything we thought it would. The proper response for this question is to choose answer choice D.